Hi guys, my name is Paul Carrion. I am going to be talking to you tonight about Jupyter and its uses beyond data science. So I'm making a screen recording right now as a backup plan in case things go wonky, or perhaps you just want to hear my voice like slowed down to half speed so I can stutter and tumble over myself inappropriately. Anyway, I started out my career in data analytics and product management, so I had a really interesting opportunity to see kind of the tools that are used in data science. And when I moved into engineering full-time, I did so by getting into operations engineering. So what I mean by that is DevOps groups. I was a QA director for a while, done a lot of InfoSec work. And you'll know if you've been around the industry for a while that increasingly we've been moving technical operations people into higher leverage roles by utilizing automation and programming. So the classic is seeing systems administrators become DevOps engineers, which basically means systems administrators that can program a little bit and get paid 3 times as much. But my kidding aside with that, there's been an incredible amount of productivity that's been gained there. However, there are some limitations. One of the big ones is that the problems that you are exposed to in technical operations tend to be very diverse. You're dealing with systems you don't know super well. You're dealing with kind of one-off troubleshooting type experiences oftentimes. So a lot of the things that have been developed for software engineers, the IDEs, the modularity, using agile or exhaustive unit tests, those sorts of things, they don't translate very well, or they provide, let's call it like a limited amount of upside for ops people. So what I'm going to try to convince you of today is that we can use what's called the exploratory programming paradigm, as exemplified by Jupyter Notebooks, this entire ecosystem, to embrace these challenges. And what's fortunate here is that within the scientific programming and data science communities, there's already been a lot of work that's been done here that we can just kind of borrow from heavily. I had to throw a William Gibson quote in here. My license plate says Ash Pool on it, so I'm a bit of a fanboy. But it's one of those great cases where the future's already here, and we just have to borrow from it, right? So when I say exploratory programming, what do I mean? Great quote here from one of the guys that makes NBDev, which I'll highlight a bit later. It's just basically the recognition that most of us spend our time as coders exploring and experimenting, right? That's just the reality in which most of us live, and certainly as technical operations people. So you can see why the conceit that I have hopefully pans itself out. Okay, so minor caveat here. This is going to be a different presentation than I think a lot of them that I've seen. I've had a great time chatting with Moshe Zadka. He's been incredibly generous with his time, really encouraging about putting this talk together. But his warning resonates wonderfully with me, and he says that this talk is going to be like convincing people to use Emacs. What does he mean by this? Well, Emacs is this very, very powerful but very broad tool. You kind of have to buy into and get fairly deep with it before you understand what it's going to do for you, right? It's not going to take 2 or 5 minutes of looking at a tutorial to be like, oh yeah, that solves a problem for me. What I want to do here, and what his suggestion was, is to show a bunch of demonstrations of the power of Jupyter and its ecosystem, and you can figure out how to do it later. I've even been kind here, and I'm going to put the coding examples up online. In fact, I already have. So you can kind of get that tutorial element right there. All right, so what is Jupyter to me before we dive into what it actually is? Let's talk about conceptually what it is. It's a mashup of a shell, a REPL, and an IDE. I usually go to Jupyter when I'm not just running like a single shell command or a completely throwaway script. And definitely I use a regular IDE when I'm doing scalable software development. I follow those patterns for a reason. But for everything that fits in between there, I love to use Jupyter for a variety of reasons. I threw a joke in here because I've been told that people think that jokes and talks make for a good speaker, so tick that box, thank you. But finally, I think, and hopefully I can convince you that one of the most exciting pieces about Jupyter is that it acts as executable documentation. I was a really big fan of BD, the stuff that came out of ThoughtWorks in London in 2010, 2011, where they talked about a process by which you created a shared language between business stakeholders and developers, and you provided tangible examples. You provided documentation that you actually could execute in the form of things like cucumber tests. I think that a lot of the benefits of that style of thinking and that style of design play out really, really well in Jupyter, and we can leverage here without a lot of the downsides, since anyone of you that's used Cucumber, I'm sure, knows the caveats abound. Okay, so here's the link at the bottom to where you can go to follow along at home. I've shown in this slide sort of the minimal mechanics you need to know to understand what I'm doing on my keyboard while we're going through this talk, right? So let's dive in. We'll show you a couple of little things. First off, you can just go in here, and by here I mean in GitHub, and you'll actually get to see a really nice rendering of the IPython notebook if you want to follow along that way. But I'm actually gonna run some of these things for you, and hopefully this won't mess up too badly. Okay, so you have a choice of having code cells and markdown cells. Obviously the one I have here is markdown, right? And just common standard markdown. The kind of REPL experience that's available here is you put your code into a cell and you hit Shift Enter to run it, like I just did, right? I can use the arrow keys to move around between cells, so up and down arrows, and the Enter key to add new lines within a cell, like so, right? So you kind of hit the boundaries, and I get this kind of REPL experience, which is pretty neat, right? But true to my word, let's dive in a brief way to introduce a couple of main pieces about how Jupyter works that are interesting that should be interesting to you in kind of understanding what's going on here. But again, I'll show as demos rather than sort of doing a tutorial. Okay, so quickly, Jupyter runs on a kernel, usually the IPython kernel. It can use multiple languages as a result, which I'll show you. It's going to run as the user that you start the Jupyter Notebook process as, meaning that it has access to do a lot of interesting things on the system where it's running. It doesn't have to be your own system, incidentally. And then the actual GUI that you're working with is in the browser. It's just a web page like anything else. That means that we can hack it to create interesting user experiences. And finally, at the core of it, it's just JSON, right? That's the data structure where all of this kind of lives. Okay, so first, I just want to point out that the notebooks also have sort of an IDE light element to them. I've got autocomplete running in my notebook. You can also look at, let's see here. You can also look at, this is an example of a debugger that's being run here. And I actually, rather than just linking or showing you this animated GIF or GIF or however you want to pronounce it, because this is a web page, I can actually pull HTML directly into it, which is kind of neat. Okay. Notebooks are multilingual and multi-purpose. Let's take a look here. Oh dear, that's a problem. Well, how about that? There we go. Okay, here's some simple examples. I showed you previously that I'm just running Python. I hit Shift Enter or whatever else. But you can also use Bash natively within the standard setup. The double modulos is called a magic method. Basically, that turns the entire cell. I think about it like a decorator for the cell, right? It turns the entire cell into Bash. So I do that, and I get the output that I echoed out, right? What I think is super powerful about this is that you can use this bang operator to sub-process out everything that happens after the bang, right? So if I do that, I don't have to use the bash magic method, right? It also allows you to mix and match, which can do some really, really neat things with Python. So in this case, for example, I'm running dig. I don't have to go find a Python package to do it. I'm assigning the output to a Python variable, and then I'm using native Python functionality that I have to pull out this IP address. I used to do this either writing everything in Bash, which was a complete nightmare for me. Not being someone that grew up in Linux, coming from a different part of the world, so to speak. Or I started to use here docs, which if you ever used are kind of painful. Happy to show you that later. So the other thing I can do is use the output that I have here in the next cell. So I use this underscore and bada bing, bada boom, I'm manipulating it. Okay, so this is probably something I don't want to do in a demo, but you can do some other really interesting stuff here. You can see here, for example, that I pull a GitHub token out, and then I string interpolate it in just by using the curly braces, right? And then in an example like this, and these are based on things that I do with consulting clients and with my day job, by the way. I can do a for loop through a set of repositories, and rather than using the, let's call them like Python package APIs, I will use the bash commands that I'm actually familiar with, right? So I cd into this rather than using OS, and I can just do a git pull or a git clone or whatever else, right? And so I like doing a lot of this kind of mix and matching. It also gives me, actually we'll talk about later, it gives me something that I can go back to and refer to. I can copy and paste and reuse again. You can imagine in a case like this, for example, that rather than, for the first time, if I'm using a repo, I wouldn't have this git pull bit, I would delete it, I would use git clone, right? So I could sort of copy and paste or comment out these various different lines. I also wanted to point out this is all running as my user. It's all running in the virtual environment that I have. You can see that here, right? Pretty cute. I guess you can't really steal my token, but maybe you could, I don't know. Anyway, let's go back to what we got here. All right, so one of the other interesting things that happens because we're running the kernel somewhere, it doesn't just need to be on my local machine. So one of the things that I've borrowed from high performance computing is you can run the IPython kernel on a remote host and then port forward it back. So you start an SSH tunnel and you port forward. And one of the places where I found this really useful, both to be able to use my notebooks on remote machines, which can be really great, particularly if you're storing some of the content like I showed you, kind of repetitively using it. But also it means that you don't necessarily have to pull passwords or things like that in. So at Adapar, we got ourselves into a setup where if you were a data analyst, we could spin up with Jupyter Hub, which I'm happy to talk about later. Basically, each user had its own Docker container spun up with a root volume attached for that user. We had an idea then from the user what sort of access they should be allowed to have, and we would allow them access to use effectively that Docker container almost like a jump host, right? So it could have the kind of access that we wanted, but we were never having users pulling secrets or privileged data sets or whatever else onto their local machine. It was all living on the remote host, and we could control that, right? Hacking the browser. All right, here we go. Hacking the browser cell. Okay, so you can do all sorts of fun browser hacking to control the notebook. A lot of them involve extensions and widgets like this. But we'll show you later that you can style the notebook or whatever else. What I wanted to show here really was that I could get into the developer tools here, and I could do some manipulation here, right? So in the original example that I had, I moved hello from that cell to this cell, right? So another really helpful thing here that you can do. Actually, I'm going to run this again with this JavaScript magic method. I'm going to run this here, and it's going to show that for any individual object that I'm working with, within Jupyter, pardon me, that I can actually pull out the methods that I have here. So you can do an awful lot in terms of hacking the different pieces, such as this cell. Rather than just copying and pasting get text, I can grab it from any of these other things. I can show you some interesting stuff that you can do later, but it does allow you to programmatically manipulate, text that's in cells effectively, rerun things, have output show up in different places, et cetera, et cetera. So it can be really powerful. You also can extend this, and I'll show you an example of that a little bit later. Great. So, JSON. JSON is the soft, chewy center of Jupyter. Let's take a look at what the actual text looks like. I think I had it here. There we go. So this is from the minimal mechanics only example that I had. You can see that it's storing, for example, the cell type. You have the source that's in each one. That's the markdown that I had. You also look at the things like the output that's separate from the source, the execution count, etc., which can be really useful. There also are some downsides, and I'll get into that shortly. But let's focus on the upsides, right? So, the fact that we are saving everything in a notebook as JSON means that you can include the state of the notebook, whether it's partially done or completely done or whatever else, and you can pass it around because it's just a JSON file, right? So I've seen places where we've attached them to tickets, we've emailed them around. We've had, for example, a run book that I'll show you later for onboarding and offboarding people. We could go partway through, attach it to a ticket, mail it to the next person on call, whatever else, would just be picked right back up. We also did some really interesting things with certain clients, consulting clients of mine, where we've provided sets of tools to collect diagnostics. So, because you're giving someone, or you can give someone a Jupyter notebook in a virtual environment, for example, and I can show you an example of something like this later, where you use a simple command like /launch, excuse me, a Docker container spins up. You run the IPython kernel, and then you run the notebook itself against it. When you're in a situation like that, you can collect diagnostics. You can look at, for example, how many times the notebook's been used, how many times it's calling a particular endpoint, what cells people are repeatedly using, et cetera, et cetera. But you can also see exactly where someone ran into trouble, which is extraordinarily powerful, right? So I call this both chewy and crunchy because, like with cucumber tests, as I mentioned, you get this kind of executable documentation feel. You can also pull out sections of helpers like you can within Cucumber, where you can define, you can define resources effectively as code. You can reuse them across the set of runbooks, which is really neat. All right, so more things about what you can do, and I've segmented them a little bit more granularly. Okay, we're going to talk a little bit about progressive automation, and this is something when I've talked to certain people, Moshe is one of them, that they think that this is the most powerful thing for operations folks. And by progressive automation, I mean two different things. So let's start with a very simple runbook example. Where is it? We want the stateful runbook. Here we go. So this basically shows that you can hold the state of a business process within a notebook. Like I mentioned, this becomes kind of something that can be, at least in the workflow that I introduced this in. This is a generic copy, of course. The individual that was in charge of the onboarding or offboarding would make a copy of the notebook. They'd fill in the date and name. They could comment out anything that they did or didn't want, whatever else, and then they would run it, right, in order to figure out how to move forward, right. So by progressive automation, let me talk a little bit more about here. Okay, so I'll show you an example later. Oftentimes, I've kept the guts of this notebook in the actual notebook in cells. You can see you can hide these cells, using JavaScript tricks, or you can just put all of this kind of behind the notebook, right? It can just be a script that you're interacting with, or a library that you're interacting with behind the scenes. I just wanted to show you what it is, right? So I've got the state here, and I've got documentation links. As you're onboarding, these are the things that you're supposed to be doing, right? You see I made this cute little onboarding class. It basically randomly allows you to check the status of the job. So, here are the things that you've done. You can skip to the next task by using next, or you can finish a task by using this done method, right? So let's say the first thing that you get when you run this is that you should get access to system 1. You click on this link to be sent to the job that you need to do to add them. You could skip it by saying next, and you could say you're done, and it'll bring up the next item. You see here, these are kind of simple, right? Or excuse me, I shouldn't say simple. They're very, very much lacking, right? But what's really valuable about this and this way of presenting this is that, for example, as I'm going, I've laid out the business process the way that I want it to be. I've documented what the business process is. I've said, hey, you've got to go to this link. You've got to request access to it if you don't have it. That gives you an opportunity to automate individual pieces of this, even if you don't really understand the business process in its entirety. So I've worked with folks where I've built something like this, I've walked through it with them, and then we've looked for these places where I or a consultant or someone else can jump in and automate small portions of this. Again, if you couple this with some of the diagnostics that I was talking about, it gives you an opportunity to say, for example, people are spending a whole bunch of time adding people to Docker, but adding something in your bug tracker UI is so trivial, we're just going to automate this piece, right? The other thing that's very interesting about this in terms of progressive automation is that I'm running something and I'm checking status, or I always can check status to see where I'm at. I can always skip something. It's not like a script where I run a script and I don't know, I guess you could do this using inputs, or people do this using CLIs, but it's really nice to be able to have a clean way to interrogate what is going on and to be able to say, for example, like, oh crap, this person doesn't have GitHub access. Well, of course, they're not going to be able to have access to System 1 because we're using GitHub as the auth mechanism here, right? But hopefully you can get a sense of what I mean with this example. Okay, we're going to move into sort of the intelligent and living documentation. This is another progressive automation piece, though. I am going to delete this for later. Oops. Hey, if you're watching this after the fact, pretend like that wasn't there. Haha. See, isn't that beautiful? Okay, so I mentioned there was sort of interesting things you can do by pushing some of these pieces behind the scenes. There's also interesting stuff that you can do in terms of this progressive automation, where you take advantage of the fact that you are running this notebook as the user themselves. So I built this, as an example for basically picking on someone who was being a jerk to me, but looking at picking on their documentation. So they were talking about running Minikube and trying to help developers install this, right? And they made this massive, I'm talking like 17-page document with all sorts of crazy crap in it. I said, well, wouldn't it be interesting to replace this with something that was more tailored to that individual, right? This would suck massively less than Confluence and sort of the Confluence way of doing things. So in this first example, I demonstrate how you can check to see whether Docker is installed already. So Docker being a prerequisite to running Minikube. So, a huge amount of the documentation that they had was about installing Docker first. And actually, they linked to another document. In this case, it was also 30 pages long or some ridiculousness for how you, would install Docker, right? So why would you do this? It clutters up the docs. It's something else that you have to maintain. I'm very fond of saying that documentation rots just like code. It's very, very true. So why not have something like this where you're checking to see whether the person needs to install Docker or not. You can even use some of the tricks with Markdown, though I haven't done it here, to just not even bother showing this if Docker's already installed. Similarly, you can do something to figure out whether the user is using a particular OS or not, and I show that code here. And this allows you to both select the correct and only show the correct information that you need to run this next command, which I might add, because of being able to use the bang syntax or that sort of magic bash method, I can run it directly in this in this notebook, but also I can say insulting things to people about the OS that they're using, and I can do it dynamically. All right. And finally, I'm not going to go into this too much here, but I'll show you some examples later. But there are some. I just couldn't get this to work in time. There are some options to use things like IPython widgets to be able to display UI elements, right? So in this case, I try to set something up where we would auto detect, where, based on the locations that we were guessing at of where these things, or where the installed code might be, and then actually run Minikube itself, but it was borked. So sorry about that. I'll show you an example a little bit later. All right. Okay. So that, I think, leads us to a very interesting other thing to discuss, which is that notebooks are a great way to co-develop tools and products with domain experts and non-technical users. I haven't seen the talk yet because I'm recording this ahead of time, but the person who's giving a talk before me about Google Colab, I think that they're going to touch on a lot of the same things. Hopefully there's some alignment between these two. I think that's going to be a really, really fantastic talk. But what I mean here, and I'd love to get a full talk on this at some point in time, is that within a notebook, you can make things a lot less scary for people that are not programmers, that may be domain experts. They may, they may not be they may not be as well versed. I find with a lot of sort of data science types, they may not be as well versed in building scalable code or talking about how to reuse things across multiple different projects. So if they're just kind of jamming through and building a model or trying to clean up some data, they oftentimes, people like that, particularly when they're junior, they don't do a particularly good job of identifying those places where you shouldn't be repeating yourself. I've seen in a lot of consulting clients and places I've worked, people copying, using GIFs or copying and pasting things into emails or into Slack or something else like that, rather than building something that might be reusable, right? Okay, so let's talk about this idea of a product manager API test. So I've invented this representative API called Snarf. It's totally awesome. Basically, it just checks to see whether the person whose name you put in is a snarfer or not. I don't know what a snarfer is. I'm a very silly person. I'm so sorry. And then it returns their email address, right? So the way that I had structured this was for a set of pseudo-technical product managers who are working with APIs they intended to put out there for the rest of the world. And so they wanted to have basically an executable tutorial long-term, an executable documentation in the form of a tutorial that they always knew would work. But part of the development, I encouraged them to use those sort of BDD techniques and write out some real examples about what this thing does, what the limitations were, to show some real examples that did and didn't work and how they ought to work, etc. We did wind up implementing some UI elements where we would show whether this notebook was quote unquote passing or not. I could talk about that a little bit later. We used something called PaperMill to parameterize this and then put it into their CI/CD system, which was pretty nifty. But you can imagine, like, they had a folder of these various different APIs that they were working with, or I should say, let's call them just the major routes they had for their outward-facing API. They knew how much progress they'd made against, very clear, explicit, documented examples that should or shouldn't work, etc. And I think that was a really, really valuable thing for that team. And I certainly would encourage you, if you have more of the programming bent, which I assume you do, given that you're at a Python conference, to think about how you could help product managers or sort of business stakeholders gather this sort of information in a clean way, like what I'm describing. Okay, so in a case like this, I've actually done what I described, and I pushed all of that messiness for this API behind the scenes. I'm just importing from a module that sits right here. See? So I can run this, instantiate the snarf example, run this email search method, and it'll get an email here, right? So what are some other cool things you can do here? Well, we can also demonstrate that snarf should be case sensitive, right? Or maybe it shouldn't be case sensitive. But this is an example of a test that you might want to run. In this case, I just printed out test failure. But in a more sophisticated example, you may want to write a data structure or something like that that can then be collected at the end and reported on, right? You could also do some fairly complex stuff, right? So here's an example where I use a JSON schema to define a required schema that I'm expecting. And this was really useful for the front-end developers and also the users that were going to use the API that had these requirements to ensure that the folks developing the services behind the API followed this required schema, right? And so you can see here, I'm validating against some test data. It should fail here, it should pass here, etc. So you can write some sort of validate, method that ensures that you're doing the behavior that you want here, right? As a final piece, I did something here where I used another magic method with time it, so we could actually do performance tests. This was really interesting to put in front of a much less technical product manager. In this case, it was scientists, so they were technical in their own way, right? They understood what they were doing in terms of having replicates of timing things and making sure that you were looking at you were looking at the right kind of measures, right? That you're looking at a mean plus or minus a standard deviation, right? So in a case like this really helped them to be able to say, well, we need to define a latency that's appropriate, and that you can only drop below that latency a certain number of times, for example. So you're starting to get into the, it's like an SLA or SLO type definition, but you're making it much, much more accessible to someone that might not have that kind of vocabulary, and they can also play around with it, right? So I made a fake slow performance endpoint. They could have used this against a real endpoint and run these tests. Incidentally, run these performance tests every time this entire notebook ran to see how often it failed, right? So that's kind of neat. All right, so here's something that I need to push. Excuse me. I need to actually stop the notebook that I have. I have not gotten it to play nicely with the notebook that with the notebook where I have all of the code. So unfortunately, you're getting this kind of garbagey look right there. But anyway, this is another example of how we can push state behind the API. Here's what I've got. I'm really glad this thing spun up properly. So I wanted to point out that I've hacked this to look different than the other one. So I'm going to go back to the previous snarf. You can see there's a Jupyter logo here. There's a bunch of other crap running around here. You saw this is the way the execution stuff looks. In this case, I've replaced that. This was with my colleague Matt Reed. Incidentally, he did probably most of the work. So thank you to him. You can see that a lot of items are missing that are distracting. And you can see that we have new drop downs, right? That's pretty cool. So what I've done behind the scenes, let me pull this thing over. And I still need to figure out to what extent I can can put this out open source if anyone would be interested. So definitely let me know if you are. These are a set of functions that we've used to inject custom JavaScript and custom JSON, or excuse me, custom custom CSS. I'm so sorry, in a really clean way. I've also used this .launch command that I mentioned. It's going to pull down the most recent Docker container, run the kernel, do this injection as part of the boot up, etc., which is pretty neat. you can see something that looks like this, right? I also have a set of custom JavaScript that's going to get injected. That's how I do the menus. You can see I can do some really interesting things, for example, to have people link to API documentations with an external link, reset their CSS, reset their JavaScript if they're developing here. But what I really wanted to point out was, take that snarf example that I had. You don't even have to have that code there. You can actually offer snippets here, and this is the snippets extension, where you could say in some sort of natural language point, you're going to set up snarf here. And what that's going to do is inject into the cell that you're in, the code that you need to instantiate the snarf object to start to work on, right? The next item on the list, for example, could be something I pointed out, running that email search, right? You could put an example here, and that would be injected in, right? And I have trouble getting this to work sometimes, but yeah, see the example I've got here? That could be injected in. You've got those drop downs here, right? Which is pretty clean and really neat. So I've actually done quite a bit with the Autopar crowd, with the data analyst that we have there. I won't be able to get into it too much. I could talk for probably an hour. I'd love to do that at some point with a colleague, Mike Lennick, who's now at Apple, the data scientist at Apple. We worked really closely on this with Matt Reed at Autopar. Basically, we would work with data analysts who were deeply involved in understanding finance, understanding how to play with financial data, looking for problems with financial data and how it's reported. But we would take some of the items that they were doing in Excel. Oftentimes they were running out of the number of rows that they could work with, etc. We could start moving that into pandas, which is a data frame system that Python uses, and we could provide these kinds of drop-down methods that had English language descriptions that would map to code like this that they could run. We got into a really good rhythm with these folks once they started seeing value here, because they could say things like, for example, in the email search, well, maybe we need to have another parameter that says, I don't want you to check that this person is a snarfer, because that's not what we need right now. I just want to check that this person's email is in your list, or something like that, right? So there were lots and lots of opportunities to use this. And I can get into some of the other things that we did with that later. And finally, I wanted to show you, or I should say finally in this arena, I wanted to show you some more browser hacking ideas. Let's get back to this guy. Go, Jupyter Forms example. All right. There we go. So what Matt Reed did here, and I don't want to take any credit, this is all him. It's very, very clever. We were working with a client together where they had developed a Python SDK, and they were using that. They were using something that looked a lot like the snippets example that I showed you, where they could go to a drop down, see some sort of English language item, and it would inject the code here. I said, okay, well, one of the problems that we're having is people parameterizing this and struggling to parameterize this, right? Or struggling to understand what kind of parameterization were allowed for these methods, right? The way that we solved for this was basically to say, okay, look at the set of methods that you have on an individual class. From the parameters that you can take for these methods, figure out what type you're actually working with. So we use type annotations in this case, and then generate from that a UI, right? So I could type in to the what parameter ASDF, and then I get this code that should be run next, right? And that's going to fail. Okay, it's not defined, but whatever, right? You can also see that I've hacked the play button here, or I've made a little play button to make it easier, kind of like with Colab, for users to figure out what's going on here. But we can create some fairly complicated forms for people to work with, and then generate the code that is based on these inputs. and provide these kind of helper pieces. And so that was a really valuable exercise, I think, for us to think about how we could again further democratize what we were already doing in Jupyter notebooks for a much wider crowd. And I thought this was a really cool thing. I'd love to put this out a little bit more broadly to the world if people are interested. So I'm getting to the last couple of examples. Here's, I mentioned in the description, the operations development environment. I didn't get as far with this example as I thought I could. I mean, obviously I've had to write a lot of code and put a lot of Jupyter notebooks together. But I wanted to take a riff on the exploratory programming model and how it might be used more broadly in operations. So the way that I see the world in this case, and what the ODE kind of wants to tackle, is if you're in operations, you've got these absolute massive streams of information that are kicking off alerts, monitors, telling you need to patch things, their access requests, their JIRA tickets coming, whatever else, right? Some of them are more actionable than others. Some of them you're going to get more often than others. But in an ideal world, you'd like to be in a case where it looks kind of like, I guess it's kind of like a SOC, a security operations center, where you get this like prioritized single list of the things that you need to do, right? And I've seen some cute examples of this. I know Octarine and Bridge Crew both do some really interesting riffs on this kind of mental model, where you have a long string of alerts. You effectively you say, well, I've got a set of goals that are checks of your system and your system state, and then you go through them and basically triage, right? So the goal here with the ODE is to build a tool where you can, in an online sense, be orchestrating the response to all of these things that are happening, right? So an example of a library that I'd like to make available to people in Jupyter very cleanly would be to say, oh, I've seen, for example, an access request here that needs to be sent to a JIRA ticket so it can be properly documented, or the service owner can actually interact with it. I want to send this to Slack, whatever else. It also gives you an opportunity to do remediation in that progressive automation style, right? Where I can manually remediate this in a notebook or in a notebook cell. I can develop a script. I can develop a library where I can kind of combine together different pieces in order to do my remediation. You can go anywhere from this kind of human in the loop type automation where it's like, hey, do you want me to run the script to remediate something? Let's check and see if this did what we expected it to, all the way to full automation. So I can actually remove things from this massive stream of if this then that type actions, and go from there. Also with the kind of the Bridge Crew Octarine setup, they do a lot of interesting stuff in terms of storing state there in whitelisting or excluding alerts, because as I've shown you, you can store state with Jupyter itself. We can do that whitelisting really cleanly as well. This also is a nice opportunity to think about where you want to add more and try out more systems invariants. I have a lot of Jupyter notebooks at my current job, for example, where I'm kind of using them to probe system invariants I think are true and look for places where those things fall through. And then I can think about how I want to automate that thing. It's very exploratory. But I can also include this, and again, because I've got this freedom to remediate in some cases, exclude in other cases, whatever else, or basically just have things continue to be alerts that kind of annoy me until I actually want to deal with it, versus things where I have to solve them right now, I get a lot of flexibility there. And that's been a really great opportunity to use Jupyter in an operations setting for a lot of value. And I hope to be able to produce some more open source that I can share with you here to do basically clean ways and examples to do some of these things. It just didn't happen in the time frame that I have. All right. Well, to wrap this thing up, we're going to talk about some limitations that exist with notebooks. So sort of the reasons why this doesn't replace my terminal right now. Okay. The biggest thing is that other people don't use it, and that's one of the reasons why I've wanted to, put this out there, to give a talk like this, to put some of this code out there. I hope more people will use this and use this as a jumping off point to do more interesting things with this tool and with this ecosystem. So beyond kind of that Sounded pseudo whiny, I guess. I don't know. But beyond that, there is a lot of trouble, I think, with scaling. There are tools to do diffs between notebooks, but the fact that you're dealing with JSON means that you're oftentimes getting a lot of cruft. So if you're diffing the number of executions a cell had in one case versus the number of executions a cell had in another case, you probably don't care, right? But that's a tough thing to do. There are some products that are out there. MBDev does this as well. MBDev also has some tools for pulling scripts out of a notebook. So I mentioned there, this sits in this kind of sweet spot between the single use and the scalable software development. It's really nice to be able to extract scripts after you've been playing with it, going through this exploratory case, to extract them out and be able to run them, run them over and over again. So the stateful nature of the notebooks can also be really painful. Darn it. That's not what I wanted. Out of order runs. Let's see if I'm gonna just look at that here. Ooh, cute. See? I like backup plans. All right, out of order runs. A lot of what one of the advantages of Jupyter is that you can hop around between different cells. You don't have to execute in order, unlike the way that you write scripts. You can see here, I've done something where I've got myself into trouble, where I've run, for example, thinger, and it equals 10. I run thinger again, it equals 20. I print thinger, I get 10. What? Well, it's because I ran this out of order, right? So I can kind of look and trace the execution numbers to understand, what the path was to get to the result. But I've been bitten, and in some cases pretty badly with this. You can imagine a case where you're pulling, let's say, from an endpoint, a list of things that need to be deleted. And let's say you've saved the state here. You try to go run it again, and you delete the wrong things. That could be a really large problem. Another place where people commonly get into problems with Jupyter and state is like with a lot of scripts. People will accidentally, they'll save secrets or things like that into the notebook, and they might push it up into version control. Okay. Another thing I think is more, I think these are more, those are things that you can solve for, I think. Some of the more fundamental problems I have is that, for example, this doesn't really run bash. It's actually running sh. You're sub-processing out to something else, so I don't get to have my aliases, which is a real problem. The final thing, I think, and I did a blog post about this. I'd love to do a grander talk here. And particularly as a lot of the stuff with Jupyter is evolving. Here, let me show you the VS Code version of Jupyter. You can see how you can execute these individual cells, but you also get the advantage of using everything else that VS Code has to offer. The reason that I bring this up is that I've made a lot of use of this sort of executable documentation in sort of a different way. So what I do in this case is I store a large number of commands that I use over and over again. If you didn't know this, it's really cool that, let's see, you can run a command. You can run a command that's saved to a file here by pressing Control-B, and it will run it into the integrated terminal, right? This is in VS Code. VS Code is the integrated terminal. I've attached basically run whatever is on the line that my cursor is in the terminal here as a hotkey, and Control-B in my case, right? So one of the ways that I hop around between different machines and run a set number of commands and search those commands, again, like executable documentation, is using VS Code. And I have some other examples here where I create runnable documentation. This is an example of doing Kubernetes the hard way, where I copy and paste this into VS Code. You can imagine copy and pasting this into a Jupyter notebook instead. But it's really nice to have this rather than in Markdown like this in a form that's actually executable. And finally, this is an example. Well, this is the example of doing exactly that. So I'm hitting Command B and having these things run, right? So the the problem that I have here with Jupyter is that I can't really do that Command B trick here if I'm trying to document what I'm doing, right? I have to have the IPython kernel running on a remote machine. If I want to use, for example, or let's say I want to generate with that kind of mixing and matching of Bash and Python, I wanted to generate a set of commands that I wanted to run. I can't really do that in a way that's executable. The output I would then have to copy and paste into another cell and run. And again, because this isn't really Bash, I can't use a lot of my helper functions. For example, I use kubectl. I've just turned into K. There is a way of importing your aliases in, but I find this to be kind of a clunky way of doing it. So I'm really hopeful that we can use some of the new Jupyter functionality that's available in VS Code to do this in a clean way. I just find it so much easier just to type out those kind of pieces of documentation and go from there. I'm going to skip over this, but I mentioned you can use something called Papermill to parameterize notebooks, so they can then be run using CI/CD, or they can be run just like they're a set of code. I believe there's some other projects that allow you to do things like that. Also, MVDev looks like a really valuable offering. It's a set of helpers that help you do like real software development, so to speak, where you basically can extract what you're doing out of the notebook and into the typical tools that you're working with. So I use that to generate scripts. It's pretty slick. So as a final slide, I picked the talk title from DHH's 2019 RailsConf, Fix Me. I think that there's an opportunity to kind of smooth a lot of the sharp edges in technical operations, and in particular programming and technical operations, for people who are entering, or people who are trying to level up from being like a run-of-the-mill systems administrator or a script kiddie. Software is eating the world. It's really painful to get started. It's not super welcoming. And it would be great to use some of these tools that already exist and adapt them into this operations world, into things like QA automation, where I see lots and lots of people who are going to boot camps, starting to get their feet wet in the world of programming. I think tooling is a great way to help an entire new set of people. And I'd love to talk to you guys about how we can extend some of the demonstration that's seen today, ideas that you have coming out of it, ideas that you had before this and I didn't get to because I'm feeble-minded, I guess, in some ways. So help us make it all better. Help us move forward here. That sounded like kind of a half-hearted attempt at being, I don't know, open or something, but I really, really mean it, even if I'm stumbling over my words. I think this is a great avenue to make things a lot better. Finally, I wanted to say thank you to all of you for paying attention to this, for watching this video. Thank BAyPiggies for all the content, everything that they've done here. Grant Jenks and Moshe Zadka have been really instrumental. Grant spent a lot of time teaching me how to write Python and introduced me to notebooks. Moshe went over a lot of this talk with me. The entire Adapar crew, but particularly Matt Reed and Mike Lennick, who are my partners in crime with using notebooks to co-develop products there. They've been a great help here. And finally, I wanted to thank the company that I'm at right now, Primer, particularly the Infra group that has let me do all this silliness. Amy is an amazing speaker. She helped me with the slides here. But generally, the company has been really welcoming of me spending my time building these kinds of tools, thinking about these kinds of things, and experimenting, and also giving me the time to make these slides and give this talk. So to these guys who've taken my call so I can do this kind of silliness, I wanted to say thank you very much. It's a really, really great group of people, and I couldn't recommend working with them more. Please reach out if that's of interest. But thank you guys so much for paying attention. Appreciate it.